This is a little bit weird, but we're going to try a videotaped statistics help session. I'm going to start with z-scores and then move into percentiles. We're going to break this into two clips. I'm basing this on the sheet that I gave out in class today that says in-class practice z-scores and percentiles. I will work through the sheet and explain how I got to each answer. Hopefully this will help you out. If you don't know how to calculate standard deviation, don't worry about that at this point. So I'm just going to give you the standard deviation and the mean, and you don't have to worry about that. So number one says that the mean is 100 and the standard deviation is 10. So the first thing you should do whenever you have a stats problem is draw your graph. So you put the mean in the middle and then 3 lines of standard deviation on either side. That should remind you that your z-score should not be less than -3 or greater than +3. And it will also remind you that the mean is right in the middle. So in this case, we have a mean of 100, and the standard deviation is 10, which tells you that there are 10 points here, 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 and here. Your z-score tells you where on the map you fall. The z-score tells you how many standard deviations, or parts thereof, you are away from the mean. So a z-score of 1 means that you are 1 standard deviation away from the mean. The fact that it's +1 means that you're 1 standard deviation above the mean. So a z-score of 1 would mean that you're right here. A z-score of 2 means that you are 2 standard deviations away from the mean. Again, positive. So you're right here. 1, 2. A z-score of 3, same kind of thing. You're 3 standard deviations away from the mean, and you're going to the right for positive. 1, 2, 3. So if you have a negative z-score, that means that you're on the left side and your score is below the mean. So if you have a z-score of -1, you are 1 standard deviation below the mean. If your z-score is -2, you're 2 below the mean, and 3, you're down here. So if your z-score is 0, imagine what that means. You can pause me if you want to. And of course it means that you are on the mean, so you're not any standard deviations away from the mean. You're right here. So if we're working with this test with an average of 10 and a standard deviation, an average of 100 and a standard deviation of 10, and your z-score is 0, then your test score is on the mean, which means it is 100. If your z-score is 1, then you know that you're 1 standard deviation above the mean. You know that each standard deviation is worth 10, so you're 1 set of 10 above the mean of 100, so your test score is 110. If your z-score is -1, then you know you're 1 standard deviation below the mean. So you start at the mean and you subtract your 10 to give you a 90. So that's your test score there, that's your test score there. If your z-score is 2, then you are 1, 2 above, and you know that each standard deviation has 10, and so your test score is 120. And 130 if you're 3 above, and like that. Can the camera catch the writing on here? Okay. So if you turn to the worksheet, your graph should look something like this. And A is asking you, if you had a score of 120, what is your z-score? Well, you know that your average is here at 100, and you know that each standard deviation is 10, so 120 should be here, which is 1, 2 away. Now, if you want an equation to work with that might be a little bit easier, here it is. Z equals your data point, which in this case is your test score, minus your average over the standard deviation. So in this case, it is z equals 120, that's the score that I gave you, minus your mean, which is 100 over 10. 120 minus 100 is 20, divided by 10, your z equals 2. That's how we got it. If you look at B, if you had a test score of -1.5, what is your test score? You can logic your way out of this by saying, okay, -1.5 means I'm 1 and then half of 1 right here. So my score is definitely going to be below 100, and it's going to be halfway between 80 and 90, 85. Let's plug it into the equation. This time I gave you the z-score. So we have -1.5, right? Put it this way. negative 1.5 equals your data point, your test score, minus 100 over 10. Now you just use algebra to isolate the variable and solve for xi. Multiply by 10, and you have negative 15 equals xi minus 100. And now you have to add 100 to both sides. You have 100 plus negative 15, which is 85 equals xi. So whenever I give you the z-score, then you have to plug it in here and use algebra to solve and get the test score. Whenever I give you the test score, it's just this equation, z equals test score minus the mean over the standard deviation. Remember, your z-score, if it is negative, means that your score is lower than the mean. If your z-score is positive, that means that your score is above the mean. The opposite is true too. If you know the average and your test score is above the average, you know the z-score has to be positive. So if you calculate it and come up with a negative number, you must have done something wrong. On the other hand, if you know that your score is less than the average, you have to have a negative z-score. We're going to pause this and then move into percentiles, but this should enable you to do number 1 and 2 on the in-class practice. So you can do that. I'm going to post the answers on my website on Sunday so you can check yourself. And just follow these steps and use this equation, use this logic, and keep asking yourself, how far am I from the mean according to the standard deviations? We'll be back with percentiles.